Hi guys, I'm Dr. PKJ, and in today's video we'll be discussing a small topic but a complicated topic called Angle Kappa. I asked the question in the daily eye quiz on the Telegram channel, and the question was something like a large positive angle kappa simulates. The options were esotropia, exotropia, hypertropia, and more than 50% of you got this question wrong, which is actually a repeat question, but you got this wrong, and several of you have texted me for an explanation for this question. So I'm making this video. In this short video, 15 to 20 minutes, we'll basically be covering all the questions on angle kappa. I'll also tell you that even if you don't understand the optics or anything at the end, we still will have mnemonics to be able to solve this question. Now, before we start with angle kappa, giving 2 minutes to understand Hershberg test will make the whole process very simple. So now, what is Hershberg test? It is a corneal light reflex test, okay, in which basically we shine a torch light in front of the patient and we look at the corneal reflex. We look at the position of the corneal reflex. Now, normally the corneal reflex is centered at the pupil, at the geometric center of the pupil. Okay, but if there is any deviation or misalignment of the eyes per se, if there is any squint or strabismus, in those cases the corneal reflex will change in position, right? So for example, in this case you've got the left eye which is in esotropia, right? So let's say the left eye is in esotropia, which means it's moving inwards or nasally. In that case, if you can see, the corneal reflex will move towards the temporal side of the pupil, right? On the other hand, if there is an exotropia and the eye moves outwards, the corneal reflex will move towards the nasal side. Okay, so looking at the position of this corneal reflex will tell us about the position of the eye, or if there is any misalignment of the eyes. If both the corneal reflexes are centered at the pupil, that means that both the eyes are aligned and orthotropic. Now, the Hershberg test is not only a qualitative test. It tells us not only whether the eye is aligned or misaligned, but it also tells us about the degree of misalignment or the degree of squint. Okay, so for example, if in this the green dots basically represent the corneal reflex. If the reflex is at the center of the pupil, that means there is no squint. On the other hand, in position 1, if the corneal reflex is seen at the edge of the pupil, right? This is the pupil, this is the cornea, right? So if basically the limbus. So if the corneal reflex is seen in position 1, that means it is noted that it represents around 15 degrees of tropia, 15 degrees of squint, right? Basically 1 mm is equal to 7 degrees of tropia, right? And every 1 degree is equal to 2 prism diopters. So we can say that 1 mm displacement of the corneal reflex represents 7 degree displacement of the eyes and 15 prism diopter displacement of the eyes from the normal position, right? So in position 1, there is around 15 degrees of tropia or squint, whereas if the corneal reflex is at the limbus, then it represents around 45 degrees of squint. Whereas on the other hand, if the corneal reflex is seen somewhere in mid iris, then you can say it's around 30 degrees of misalignment or tropia. Now, with this background knowledge of Hershberg test, let's look into the various visual axis as well as the angles in the eye, which will basically give us information about the angle. Now we need to understand two important axes in the human eye, right? The first is the visual axis and the second one is the anatomical axis or the pupillary axis. Now, any object in the visual field will be seen by the fovea, right? And the path the light travels from the object to the fovea, which also happens to pass to the nodal point of the eye, is known as the visual axis. So basically, visual axis is an imaginary line that connects the object to the fovea, right? The next line we need to understand is the anatomical axis or the pupillary axis. Now this is a very simple one. This is basically a line drawn perpendicular to the pupillary plane, passing through the center of the corneal curvature, right? And it basically divides the human eye into two equal halves, right? It divides the retina into an equal right and left hemiretina. Now you can see in the image below that the blue visual axis and the orange anatomical axis or the pupillary axis, they are not coincident. They are not parallel, right? And there is a reason for that. There is a mechanism. Basically, if you think of it, let's say you are shining a light onto a mirror or a refractive surface exactly perpendicularly, right? When you do that, you are going to have a glare, you are going to have reflections, and you are going to have aberrations, right? So the nature's mechanism is so built in that the visual axis does not enter the eye exactly perpendicularly, right? It enters the eye at an angle. That is basically to reduce the glare, the aberrations and reflections, right? Now what that does is that there is an angle between the visual axis and the anatomical axis, and this angle is what we call angle kappa, right? So angle kappa, remember the mnemonic PVK, and that basically means the angle between the pupillary axis and the visual axis. Now you guys know that the optic disc here is located nasally, right? And the fovea is located temporally, right? So you can see that the fovea is located temporal to the anatomical axis, right? It's on the temporal side of the anatomical axis, whereas the disc is on the nasal side of the anatomical axis, correct? Now because of this arrangement, on the visual axis enters the cornea on the nasal side, on the nasal half of the cornea, right? And wherever the visual axis or the light is entering, there is bound to be some reflection, right? This is the site of the corneal reflex, right? So we know that the angle kappa is the angle between the visual and the pupillary axis. We know that the corneal reflex is on the nasal part of the cornea, right? This is how we measure the angle kappa clinically, right? Basically, corneal reflex is nasal, and for a normal human being, for a normal eye, this distance is around 0.6 mm. The corneal reflex is 0.6 mm to the nasal, to the geometric center of the pupil, right? Now, so guys, if you remember, I also told you that Hershberg test is a quantitative test. By looking at the displacement of the pupil, of the corneal reflex from the center of the pupil, we can give a rough estimate of the degree of tropia, right? So if it's a 1 mm displacement, it means there is 7 degrees of misalignment or tropia, right? So 0.6 mm, which is the normal corneal reflex seen, that corresponds to 4 degrees. That 4 degrees is your angle kappa, right? So we measure the angle kappa looking at the corneal reflex. Now, while we have studied angle kappa, I just briefly want to mention the other angles in the eye. These are also asked as MCQs, although it's not related to the topic exactly, but I'll just give you these MCQ points, right? So I remember them using mnemonics. So the first mnemonic that I use is PVK, like I told you, the angle between pupillary and visual axis, that's known as angle kappa. The second one is angle gamma, that is the angle between fixation and optical axis. I remember that using the mnemonic FOG, fog. And the third is the angle alpha. I remember this using VOA, VOA, right? So visual and optical axis, the angle they make is known as angle alpha. So just to reiterate what I just told you, the angle formed between the visual axis and the pupillary axis is known as angle kappa, and this angle we measure based on looking at the corneal reflex. Corneal reflex is Purkinje image type 1. So far we have seen that because the fovea is located temporal to the anatomical axis, what happens is that the corneal reflex that is normally seen is on the nasal half of the cornea. It is slightly nasal, right? It is around 0.6 mm nasal to the geometric center of the eye or the pupil, right? So because of this, the normal angle that is made between the visual axis and the pupillary axis is around 4 to 5 degrees. That is known as angle kappa. Now, by convention, this angle of 4 to 5 degrees is considered positive whenever it is on the nasal side of the cornea, right? So positive angle kappa is 4 to 5 degrees and it's due to a corneal reflex that is on the nasal side of cornea, right? On the other hand, if this reflex is seen, let's say, on the temporal side of the cornea, that would make a negative angle kappa, right? Because it's on the other side, right? So the convention states that if it's on the nasal side, it's positive. If the reflex is on the temporal side, it's negative, right? Now, normal values, I just want to briefly touch upon this. The normal value for angle kappa is 5 degrees in adults and 10 degrees in children. Correct? And by the way, 1 degree is equal to 2 prism diopters. So you can also say that angle kappa normally is 10 prism diopters in adults and around 20 prism diopters in children. So now we want to study how is this angle kappa clinically significant. Till now we have only studied the theoretical aspects, but now we want to study in what cases will angle kappa be altered, in what cases will it increase, will it decrease, and how will it affect the tropia, right? So firstly, positive angle kappa up to 4 or 5 degrees is normal, and it's because of a corneal reflex that is on the nasal side of cornea, correct? Do remember this, that this corneal reflex is on the nasal side because the foveal, the visual axis, it goes to the fovea, and fovea is located on the temporal side of the anatomical axis. Now, what happens if the fovea gets dragged even more temporally, right? So if the fovea gets dragged more temporally, the corneal reflex will become more nasal, correct? The corneal reflex, let's say this is the nose here, this is the nasal. So if the corneal reflex was here initially, now it's going to come even more nasally, right? If the fovea is dragged temporally, the corneal reflex will come more nasally, and if it's on the nasal side, it's a positive angle kappa. so the angle kappa will increase, right? In a temporally placed fovea, angle kappa will increase. Positive angle kappa will increase. Now, let's bring our knowledge of Hershberg back to the equation. In Hershberg, we said that if the eye goes out, if there is exotropia, the corneal reflex will be seen on the nasal side, right? So if there is 15 degrees exotropia, then corneal reflex will be seen on the nasal side. By how much? It will be seen at the edge of the pupil, because that was our numbers. You remember the numbers of Hershberg test, right? So in this case, if the fovea is temporal, more temporal, corneal reflex is more nasal, the positive angle kappa will increase, and in that case it will simulate a exotropia. Correct? Now it is interesting that it says its exotropia is going to be simulated, and it's not saying that it's actually going to be a true exotropia, and we'll discuss about that in a bit. On the other hand, consider this, that let's say the fovea is now more nasally displaced for whatever reasons. We'll look into the reasons. If the fovea is more nasally displaced, the corneal reflex will be more temporally displaced. By convention, a temporal corneal reflex leads to a negative angle kappa. Why? Because nasal is positive for angle kappa and temporal is negative for angle kappa. So it's going to cause a negative angle kappa when the fovea is nasally dragged or the corneal reflex is temporally present, right? Now use your knowledge of Hershberg test. If the corneal reflex comes temporally, that means the eye has moved and has deviated inwards. So that's an esotropia, right? When the eye deviates nasally, the corneal reflex is seen on the temporal side of the pupil or the cornea, correct? So that simulates an esotropia. Now with that understanding, I want to tell you what happens in myopia and hyperopia, right? So in high myopia, for example, there is axial lengthening of the eyeball, right? And because there is lengthening of the eyeball, but it's mostly axial, the fovea does not displace as much. The fovea does not displace very much. So in fact, there is relative nasalization, right? There is relative nasalization of the fovea compared to the anatomical axis. That is, it moves in closer to the anatomical axis. Now, when that happens, when the fovea moves in nasally, that means the reflex is going to move temporally. When the reflex moves temporally, that is going to produce a negative angle kappa, and a negative angle kappa is associated with an esotropia, which is a simulated esotropia. So a myopia will produce a pseudo-esotropia, right? We'll again revise this. On the other hand, if there is hyperopia, right, or even in retinopathy of prematurity, what happens is that the fovea is dragged temporally. When the fovea is dragged temporally, the corneal reflex is displaced nasally. By convention, nasal is positive angle kappa. So the positive angle kappa further increases. If it was 5 degrees normally, it's going to be 8 degrees or 10 degrees, right? And when the corneal reflex moves nasally, that, based on our Hershberg knowledge, means it's an exotropia, correct? So hyperopia and ROP will cause simulated exotropia or pseudo-exotropia. I am going to restate whatever I just told you in a slowed down manner so that you are able to understand. In axial myopia, right, what happens is that you can see this first one is a normal eye, and this one is after the axial lengthening of the eyeball. In myopia, the eyeball increases in size, right? So you can see that the bluish one is the new visual axis, right? And the angle subtended by the black line and the blue line. So the black line is the anatomical axis and the blue line is the visual axis. So that angle is your angle kappa. So in case of axial myopia, the angle kappa is smaller. Correct? Basically, axial myopia causes the fovea to move towards the nasal side, right? And because there is relative nasalization of the fovea, there is temporalization of the corneal reflex, and temporal corneal reflex means a negative kappa, or if it was 4, it can 4 or 5, the positive angle kappa was 4 or 5, it will reduce in value, right? Basically, it means it's a smaller angle kappa. So myopia is associated with smaller angle kappa. On the other hand, hyperopia, right? So let's say this one is your normal eyeball, and in hyperopia there is shortening of the eyeball. So this one is, let's say, a hyperopic eyeball. In this case, you can see that the red line, which is the hyperopic visual axis, and the pupillary line, pupillary axis, they make a larger angle. So in hyperopia, the positive angle kappa or the angle kappa increases, right? Basically, there is fovea moves more temporally in a case of an hyperopic eyeball, and because the fovea moves temporally, the corneal reflex is seen more nasally. More nasally means a higher angle kappa, and more nasally also means that it's going to look like an exotropia because of Hershberg test, right? Similar thing happens in retinopathy of prematurity, where the fovea is dragged temporally. So again, you can see this photograph depicts the pathophysiology in retinopathy of prematurity. There is temporalization of the fovea. The fovea is dragged more temporally, right? So that will cause an increase in the positive angle kappa, and because of the increase in the positive angle kappa and nasalization of the corneal reflex, it is going to simulate an exotropia, right? The left eye in this case appears more. So guys, coming back to the question that was asked in the quiz, a large positive angle kappa simulates what? So yeah, hyperopia and ROP will cause temporalization of the fovea, will cause more nasalization of the corneal reflex. So a positive angle kappa will be seen, and they will, because that's leading to nasalization of the corneal reflex, they will simulate an exotropia, right? So now the question is, why is it simulate? Why is it a pseudo strabismus? Why is it a pseudo exotropia in the case of hyperopia and ROP? The reason is because there is no misalignment of the eyes, because the foveal fixation is still present. It's just that the fovea has been dragged nasally or temporally, right? In hyperopia, in myopia, in ROP, but it's still there is foveal fixation, right? So it's causing a pseudo strabismus and not an actual strabismus. So just a quick summary of whatever we discussed. Angle kappa is basically the angle formed between the pupillary and visual axis. It is normally 4 to 5 degrees in adults and 10 degrees in children, or you can say 10 prism diopters in adults and 20 prism diopters in children. It is because there is around a 0.6 mm nasalization of the corneal reflex, right? And 0.6 mm corresponds to 4 degrees of the angle, correct? Now the angle kappa is more in hyperopes and less in myopes, and basically a positive angle kappa is going to lead to a pseudo exotropia, something that can be seen in hyperopia and retinopathy of prematurity, and a negative angle kappa caused due to temporalization of the corneal reflex can be seen in myopia, and that causes a pseudo esotropia. That is all on this topic. I hope this will cover all the MCQs that are routinely asked on this topic, and I hope you are able to understand this topic too. Do let me know because these are my starting few videos, so do let me know if you like the video. Please subscribe to the channel for more similar ophthalmology content. Thanks for watching.